Hello everyone, this is Samuel from Learn Programming Africa. I'm going to start static libraries now. I have just since I have just done the arg-v and arg-c part. I'm not going to do any announcement now, as for the coming batch. Please subscribe to this channel so that you are not going to lose any information we are going to post here. We are going to do a lot of things here, starting from preparing you for an interview to building your CV, portfolio and other things. So subscribe and be tuned so that we can do those things together. For now, I'm going to start a static library. I'm going to just do a simple demo, which is on a tutorial version. So I'm going to say, for example, ls here. I'm going to remove everything, ls. So yes, I have removed everything. So I'm going to touch one file, which is I'm going to vi new file.c, so that I'm going to include stdio.h, which is what I need, and int main void, and I'm going to undo this, print f what hello learn programming Africa. You can replace this with anything you want, and that is return 0, and I'm going to do this thing wq, and I'm going to use GCC, the compiler, and the GCC compiler to demo things. So I'm going to say gcc --help to see what is in here, so that we are going to do something here. So I'm going to compile my code so that I am going to show you everything. You can make your code executable and compile it to a binary file and link it. So we are going to do those things today. So in C program, when C program is compiled, the compiler generates object code. So we are going to compile it, ls here. As you can see, there is a new file.c only. So I'm going to compile it using gcc -c. -c flag is for compiling it. So I'm going to help here. If I hit help here and c -c flag, let's search for -c flag in here. As you can see, -c is this one, and compile and assemble, but do not link command. It is going to do compile our code, not link our code. So I'm going to gcc -c, then new file.c, and the output will be, if I let it run this code, it is going to output our file to a new file.o, which is an object file. And let's here, as you can see, there is an object file generated. Then after generating the object code, the compiler also invokes linker. For example, if we this is not let's see how we are going to link our code. So I think if I search for here, find here link, so created an anti-linked, compile only, do not assemble or link, compile and assemble but do not link, and the other thing is pre-process only, do not compile, assemble or link. this command is going to do xlinker. It is pass arg on the linker, so pass comma separator linker, and as you can see we don't have a linker here, but if we run this file on a code block or something, if we assemble an object code, or if we compile our code using a compiler, it is going to do first it is going to generate an object code, then after the object generated, the compiler also invokes a linker. One of the main tasks for linker is to make a code of library functions like printf, scanf, and square roots available to your program, so that you can use those functions. Actually, there are custom-made functions that will be available to you as well. So a linker can accomplish these tasks in two ways. The first one is by copying the code of library function to your object code. That is one way, and the second one is by making some arrangements so that the complete code of library function is not copied but made available at runtime. So that is what is going to happen. We are going to look into static library, which we are going to build, so that we were writing a code that is making, for example, if you write a code and run it, it is going to bring you an output. But now we are going to be in the middle and do something that we need in the middle by creating a static library that will be used for multiple purposes, like for example, a math square root function is written by a C program, but it is there as a static library which will be available to you upon invoking. So a static library is a result of the linker making copy of all used library function to the executable file. So you are going to compile your code and make it an object file, then it is going to be linked, then it is going to be executable file. So after it is being an executable file, you are going to do that. So you can do work on a static file on Windows as well, but it is going to have a .library or .lib extension to it. But as we are going to work on Ubuntu, I'm going to show you on .a file. Actually, static libraries take much disks and RAM if not managed, if the memory is not managed well. We are going to see memory allocations and other tasks in the future examples, but for now this is enough information. So we are going to create a clean static library, which is an example first. Then we are going to get back to our function to make something. So ls here, I'm going to remove everything from here. Ls here, clear. This is clean thing. So let's touch a file which is going to be our library. So I'm going to touch something, some file.c, which should have a a library in front, so that I'm going to say library, then underscore some file.c. This is a standard so that you have to use this thing to make your static library executable. So this is going to tell C it is a library, so I'm going to create this one. So I'm saying touch library some file.c. so this is going to be here. So I'm going to open a tutorial here, and I'm going to open this one, and I'm going to write something include stdio, and I'm going to say some function. For example, our function is going to add something, so int add int a comma int b, so that it is going to just return something, one thing, which is return a plus b, which is enough for this function. So I'm going to add another file here, touch main.h, so that I will have the these files prototype in there. So I'm going to open main.h, and I'm going to say if not defined main h define main h here as well, main h, and if, so I'm going to add here this function, copy here, v here, and continue. I'm going to remove this one, int is enough, I think. So and this is a prototype of that function, so this is the function. So I'm going to create a static file, which is, I'm going to come here, clear. So I have created a main file, so I'm going to compile this to an object, so that gcc-c which is library, actually library my file.c, the output should be a library underscore some file.o, so that it is correct. So this is, so what is, okay, this is not equal to c, it is minus c, so that it is not. Alright, stdio.h should be here, .h should be here, so I'm going to do that, and it is if I ls it, there are three files, which is library some file.c, library some file.io, .o, and main.h. So this is how you create an object file. Then to create a static library, you have to make use AR, so that let's see what AR is. Help, so that here AR is usage is like this: if delete file from the archive, so it is an archive, it is saying archive this file to an a command. So this is supposed target is this one, so I think there is no description for this. There are description here for other names, so let's skip this and let's do our thing, which is ar-l, which we are going to use is if there is a file with this name, replace it, which is replace existing or insert new, which is C is, what is C, where is C, let's find C. Do not warn if the library had to be created, just create it. And we are going to use an S, which is create an archive index. So that is what we are saying. So I'm going to say AR dash, then actually RCS, and then I'm going to say library underscore some file.a. Then I'm going to say everything with which ends in .o file should be archived here. So this is going to be done. If I ls here, this is our static library that was generated. So I can come here and copy this one, main.h, which has the prototype of the file, and I can create a new folder or move it anywhere I want. For this case, I'm going to add a test folder and copy and paste it here. I'm going to cd into this one, cd test ls. Here I have a static library and the prototype to that static library. So what I'm going to do is I'm going to use this to run a file, and I'm going to for example, I'm going to add a driver file, which is so I'm going to create touch driver.c, which is going to create the driver file so that I can invoke the static function I have written there, which is add. So I'm going to use that. So I'm going to come here, and from here I'm going to open this one, and I'm going to include what main.h as a to use that function, or to use that entry point or prototype, int main and void. Then I'm going to say I'm going to include stdio, I'm going to include it up there. So include stdio.h file here, and let's come down here and do this, and I'm going to say int addition equals to add what number 4 comma number 8, so that it is going to be simple, and print if digit sum is equals to a digit with n comma additor. So I can say, I can correct it there, and I can correct it here, or for the grammar purposes, or I can use addition as it is, that is the same. So I'm going to return 0. This is going to be my driver function. I'm going to compile this driver function, driver file, or I'm going to clear ls here. As you can see, there is a driver .c and my library function, and there is a main.h which holds my prototypes for me. So then what I'm going to do is I'm going to compile this driver. So I'm going to gcc, then compile it, which is driver.c, to actually output this file to driver.io. I can driver.io.o, or I can just say compile this file, and by default it is going to use driver.o file. So if I ls here, there is driver.o file here. So by default it is going to make that decision for me, but if I write it, it is the same. So after this one, I'm going to link a compiler or a driver function so that it is going to be executable. So I'm going to link this driver function. I'm going to say gcc then -o driver, which is the name. So I'm going to driver.o, then I'm going to say -l to look for the library, the static library in this current directory. We are going to use this thing, and I'm going to say L, then I'm going to it is going to look for library, then some file.a, some file. So it is going to look for the library, then some file, then it is going to make our driver an executable file. Then it has identified everything. So if I run ls here, if, as you can see, there is an executable file which is here. So if I run that file driver, if I run this file, it is going to print the sum of 4 and 8, which is sum equals to 12. So as you can see, we have created a static library, which is our libsum file.a, and we have made it an executable file and executed it, and it is we are creating a static library like this. So let's do this for the project. That is what you need to know about about this project. So let's go down and do the quizzes first. I have completed it, so let's see what the quizzes are saying. So what command is used to create a static library from object files? So as I have used, as you have seen, it is an archive or AR command that you use to create the that we used to create the static library from the object file. So the next one is, what is the point of using runlib? It is indexing an archive. So indexing actually means that you can access that memory faster. So the indexing is for the speed purpose or the performance purpose. So and that is that. What command can be used to list the symbols stored in static library? For example, you can use nm or ar. So I'm going to use nm here, nm and lib this one, and if I run this, as you can see, there is this function add, and 00 is the index of this function. So this is how you do it, and you can use AR with some flag to look into it as well. So what is the format of a static library? It is an archive, or it is .a file in Linux system and .lib file in Windows system. So by the way, I recommend you to use I recommend you to use Ubuntu as much as you can. If you need any guidance to install Ubuntu on your system, contact me on or comment here. We can go through it, or I can prepare a video to dual boot your Windows system with Ubuntu, or I can direct you to a pre-existing video that is already done. So that is that. Rather than that, you can actually I recommend you to use Ubuntu rather than Windows. So here it comes. So as you can see, create the static library libmy.a containing all the functions listed below. So we have done I have seen this thing, so we have done these things previously. So I'm going to copy those files into my directory, and I'm going to copy this actually through and come back here and come back here. I'm going to close these ones. Alright, I'm going to come back here, and as you can see, I have created this directory. I was to copy I wanted to copy this entire file by myself, but I'm going to go through it together. We are going to go through it together. So I'm going to create a main.h cd. So I'm going to back here, cd back cd 0x09, then tab clear, and let's touch the first one is readme.md touch main.h, and I'm going to open this up, open the up, and let me close the others. So if I come here and if not defined main h define main h, and if, so I'm going to paste it here. These are the required files, and I'm going to pick one by one, and I'm going to come here, and this is all about static libraries. So I'm going to save this as well, and as you can see, I need put char first. So I'm going to get back here, opening a tab, and I'm going to come here, and there might be put char here. So I'm going to copy it and paste it here. So the other thing is I'm going to find the other things here, steer which is in here, and steer pbrk which is here, and steer spn, and steer chr, and memcpy, memset. So steer compare, steer copy is in other place. So these 1 2 3 4 5 6 are here, as you can see, and I'm going to copy them, copy from here and paste it here. These are required here, that is why I'm doing this. So I'm going to search for these ones as well. I'm going to steer compare, I'm going back here, and I'm going to come here, steer cmp, this one is it, I think, steer cmp, steer cpy, steer cut, this one, and steer ncut and steer cut. These are what I need, I think. Copy this one, and I'm going to come back and paste it here, and I have up to this one. So I'm going to do a to I steer copy and puts something like that, like this again. So I'm going back here, and I think I can find it here. There is a to I. Have I a to I here, there is no A to I here, so I'm going to stir copy. Is there a stir copy? There is stir len, stir cpy, stir cpy dot c. The other thing is puts underscore stir len underscore is digit swap, and this is A to I is already there here as well. A to I stir copy puts, A to I stir copy puts, and stir len I think there. So I'm going to copy this one and paste it here. I'm going to get back here and go back here, and I'm going to do here, and I'm going to say is digit and is upper, is digit is upper, absolute is digit is upper, absolute, where is absolute? So there is an absolute here, and is alpha is lower, is alpha is lower. So I'm going to copy this one and paste it here. Let's again see debugging. So there is nothing here. I'm going to here, and is alpha is alpha is lower, and absolute value are here. So I'm going to copy this and paste them here. So I'm going to check from 3 to 22. It is, I think, including 3 1 from 1 to 2 2. So I'm going to minus 2, so it is 20. So I'm going to count these ones. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 and 20 with puts char. So that is correct. So I'm going to save this one, and I'm going back here. So if you haven't coded all of the above function, create empty ones with write prototype, don't forget to push your main file to repository. It should at least contain all the prototype of the above functions. So this is going to be what I'm going to do. So if I run this function, it should give me these files. If I run these functions, it should give me this thing. So what I'm going to do is I'm going to create a link function. So I'm going to say, I'm going to come back here and clear, and I'm going to say I have created main.file file. So I'm going to say gcc dash compile my what, let me take this file name libmy.a. so I'm going to say, I'm going to minimize this and libmy.a, and I'm going to say actually I'm going to make I'm going to compile everything. So I'm going to say .c files to output them to .o, everything actually .o. So it is going to say, it is going to compile each file to its own name. So there is return nil. I'm going to say so in character null undeclared, first use in this file. So I'm going to so okay, I'm going to include this, or I'm going to make that. Okay, let's include this on our what file, on strchr file, strchr file. So I'm going to come here and find strchr file. So I have used null, but I haven't defined this one, so I'm going to save this and come back here and see it is compiled. And if I come back here, if I come back here, as you can see, is upper has .o file, imames that is .o file, and everything has a corresponding .o file. So that is what we need to create our static library. This static library is going to include these entire functions which are created previously. So I'm going to go back here, clear, and I'm going to say archive rcs lib my.a, and from what files should I create this static library is I'm going to say everything.o file. So the object files should be converted to the static library. So I'm using everything, which is everything.o. So what this is looking for is in the current directory. In here there are .c and .o files, and every .o file will be compiled into the static library, our static library. So if I hit enter, I'm going to have ls, and my lib.a is going to be lib my.a is going to be here. The lib, or you can name it anything you want, but you have to precede it with lib, which is library, so that it is going to be recognized while you run it. So let's check our code by running it for the for everything they have run it for. So let's check using this one, clear. So I'm going to add a git ignore file. So touch.git ignore git ignore file, so so that it is now going to push everything I have here. So I'm going to come here, git ignore, where is my .git ignore? So I have to show hidden files, so .git ignore is here, as you can see. So I'm going to say ignore with .o files, ignore .c files. So that is what I'm going to say to it. And if I say here git status, as you can see, ls git status, as you can see, there is main.h. so clear git add all git status. As you can see, leave my.a is there, main.h is there, readme.md is there, and git ignore is there, but the other files are ignored due to the condition I have specified on this one. So don't add these files into my GitHub so that it is not going to be duplicated. That is what I told my compiler, so it is going to do that. I'm going to run something ar-t lib my.a. so if I put it like this, it is going to list everything that is required there. So as you can see, there are everything we need here. So let's clear this and let's nm lib my nm lib my.a is going to show us, as you can see, everything that is required. As you can see, steer card a to I, and mem said a to I is digit, a to I is digit, steer C and everything. Global offset table, what is this thing? Steer and cut. So there something, so cut main.c. if we run this on our file, it is going to if we at the end of the day, my goal was to be the best hacker, Kevin Mitnick, so return 0. I don't think there is going to be anything, but for everything it is going to say that. So I'm going to add this file and check if our code is correct. Git add all, git commit message and static library created git push, and if I check my file, my so there is an error there, there are errors there actually. So leave my.a and main.h should be available, but u puts char, t puts, so let's see. Global offset table, u, which is global offset table, t steer and cut, u steer and cut. Yes, this is called, and there is something added to this import, so those are something needed. So leave my.a, main.h. let's see. Git status, I think there is something wrong. ls here, if I ls here, there is leave my.a, so so let's again do this thing, leave which one? This one without s, so that there is nothing wrong now. Git add all, git commit message my static library, git push, so everything is git add all, git status, git status, branch up to date with the original master, so okay, git push, everything is up to date. So what's happening here? There is no details that is being shown here, so there is something wrong here. Leave my.a, main.h. These are the files that are required, so what other instructions are there? So bash here requirement, so this is going to be this one, Betty, you are allowed to use put char, don't forget to push your header file, cross type only function and put type 2. Okay, main.c file are shown as example. You can use them to test your function, but you don't have to push them to the repo one shown in the example file. The compilation our main.c file should be in our example, so I'm going to say if I check this one, let me do this. So let's check if this is running correctly by creating a main file which is in here. So I'm going to say touch main.c. so I'm going to come here and put everything from here in there. So main.c is this file over here, copy, and I'm going to open main.c. This one, save it here. Alright, come back here, and if I do so, I'm going to say this one here. I'm going to gcc compile my main file to the main.o file. So I'm going to say gcc-o main.o dash l in the current directory and dash l my, which is library my, and ls. I'm going to say main if at the end of the day the goal was to be based hacker, which it has returned. So I don't know what the reason is, just it is working, but I am thinking that if you have done everything as I did, which is like this one, it is going to work for you. But the reason it is now working for me, I think, is, for example, if I nm, where is my nm? Let me write it. nm will leave my .a, which is these things are making my function not working, which are these ones. And for example, I have used a global table, offset table, which is referring back there. So in here, if I have created the function without using a standard library, it is going to work. I have used here as well, so it was working for those purposes. If I do them now, they are going to be, it is going to take a long time. So if you have done this separately, it is going to work for you, but for now, unfortunately, we are not going to test it here. But as you have seen, it is working correctly for the test case that is given. So if it is a matter of correctness, it is correct, but as you can see, it is failing by every other things. Do I have basic things there? Here there is a readme. In this file there is a main.h in library. So let's pass this question without solving it and work on this one. Create a script called create this one, copy, touch this one, clear, and that creates a static library called this from all the C files that are in the current directory. So let's do that. What it is saying is, let's see if our code which we have written are compiled by GCC. So let's see GCC dash w all dash w extra dash w error dash pedantic dash c. Let's see. So if I do this, pedantic no such file. So let me do this. Yeah, it is working. So still nothing. So I'm going to vi into create.sh. Here I'm going to insert, and I'm going to say this is going to be a bash file, I think. So create a script called this that creates a static library from file that are in the current directory. So it is this one. So I'm going to vi into it. I have vi into it, and I'm going to create a bash or a shebang. First bash, then the shebang is going to make this executable, and I'm going to say the second line is going to be GCC, and it is going to all w extra and w error pedantic dash c, compile a file which is with .c file, and make them compliant with their names or complementary with their names. So this is what this is saying is every file, compile every file which is .c file, and make it available for me. So there was a storm, and there is light out at my place, so I'm going to open a mobile. So then what it is going to do is archive everything rc with so let me check what it is saying. Create a live all. So I'm going to say the name is going to be library all.a, and from everything.all. That is what it should say. I'm going to write and quit git add all, git commit message my my script to create a static library. So git push. If I push it and check here, it should be correct for this specific task. Alright, let's check if my this is correctly spelled. So I'm going to check that. Static libraries 0x09 static libraries. What happened then? 0x09 static libraries. So this is correctly done. So I don't know what is going on. Okay. It is correct. Let's chmod u plus x create library, create static library.ch with add all with commit dash n push I think this is what is left, and let's check. Yes, that was what is left, and this is correctly done. But the previous one, this one is, I think it is from my side, which is I have used standard libraries rather than creating them from scratch, so that is why it is not passing it. As you can see, this is calling bootstrap, but it is built by ourselves. But as you have seen, for my case, if I name my thing, this is a global offset table, which shouldn't be here. That is the reason it is failing repeatedly. So check that. I will try updating those by tomorrow or something, and post them on my GitHub, but I don't think I'm going to do that, but let's hope I'm going to do that and finish this video. Please subscribe and wait for us for the next one, and see you guys. Bye.